Yeah, thanks. It was nice seeing you again, Alexander. Welcome, everybody. We just share my screen here. So hi, thank you for attending my talk. My name is Dekel. I hope you've been enjoying Nodes 2022 so far and learning a lot of cool things.
Sorry, Dekel, do you mind clicking on the hide button where it says is
yes,
sharing your...
Sure.
Yeah, cool, thank
you. Yeah. Is that okay now?
Perfect, thank you.
Okay. So my talk will focus on BlueHound, which is an open source tool I've developed to help organizations deal with security issues and trying to bring that community sense to the security community and based off Neo4j and NeoDash, which I'll also touch a little bit later on. So about me. My name is Dekel Paz. I'm a senior security researcher at Zero Networks. I've been in the IT and security industries for over 15 years now, dealing kind of on both sides of the fence. So I've been doing like more offensive things, meaning doing simulation of attacks, penetration testing, developing attack tools, things like that. And also on the defensive side, both on enterprise level, trying to help companies stay safe and working on startup companies to create products to help organization protect themselves. Just a brief about Zero Networks. We're a company dealing with micro-segmentation and bringing network security to version 2.0, doing this in a very automatic and quick way. You can read more about us in zeronetworks.com if you're interested. And you can find me on Twitter at Dekel_Paz. If you have any questions regarding this talk or anything else, feel free to reach out. So I just wanted to kick us off with this quote by John Lambert from Microsoft. It says, defenders think in lists, attackers think in graphs. As long as this is true, attackers win. Now, this quote became pretty famous, I think, in the security community. You've seen it pop out a lot. And I really wanted to share it here for two reasons. First being, this is kind of puts us in the mindset of what it's like to be a security, somebody dealing with security. So if we think classically about security, we have, for example, firewalls, one of the most classic software or tools that we have. It really works in lists. You have a list of rules that says, if a network connection comes in on port whatever, from IP whatever, you should block it or allow it. So we just have a bunch of these rules. But it's more than that. We have a list of hosts that we need to patch every month or every whatever. So it could be 5,000 hosts that we need to patch. It could be we have 10,000 users and we need to make sure all of them has less permissions because we don't want each user to be able to do whatever it does. So that's all very well and nice, but attackers don't really think like that. They don't really care if you took 10,000 hosts and you patched 9,000 of them. Even though it's a really big progress, for the attacker, it only needs one of each. So he thinks more in graphs or in vectors. He needs one user that can help him get to one computer, and from that computer, need to get to another computer that has some issue, and that computer may have one open port that allows it to connect to something else. And now we're not really looking at the list, but we're looking at more of a vector path. We just need one of each really to get to where we need. And I'll show an example soon. But the second reason this quote is here, and why I really like it, because it's basically like saying, tell me to use Neo4j without telling me to use Neo4j. So just a little bit of background of what a cyber attack looks like. There's a very famous methodology called Cyberkill chain, which has a lot of steps of what steps attackers take in order to take control of networks. But I have a condensed and simplified version here, which is more relevant to this talk. So the first stage is the initial foothold. This is where the attacker does some reconnaissance, try to find maybe email addresses of his targets, IP addresses, things like that. And really his aim here is to take control of one host inside that network. So it could be sending some phishing, it can be getting one of the hosts infected, but it just needs one starting point inside the network. Once he's in, it gets to the network propagation stage, which is probably the most relevant to this talk. This is where the attacker tries to get towards his target. And he does this by basically two main ways. One of them, we call it lateral movement, which means he needs to move around between different hosts. And the second way is privilege escalation, where he tries to escalate the privilege that he has in order to get higher permissions. So for example, if you start on a very simple computer, a very basic laptop, and a very simple user that doesn't have a lot of permission, we need to jump around the network with the permission that we have in order to get to places where there might be higher privilege credentials or things like that we can steal. And then we can slowly build up our permissions until we get to a stage where we can move to the final stage, which is action on objective, which basically means doing what we set out to do. So this could be stealing some data, stealing passwords, disrupting some service, basically what we came out to do, and this is usually the end of our project. Now, what does this actually look like? So let's assume we have an attacker that took control of this host in this network, and with the credentials that he have, it tries to reach the server on the right, but it doesn't really have ways to get there directly. It doesn't have the permissions. But it does have permissions to move around between a bunch of different hosts. So that's all good and well. Now let's assume we have an IT admin in that network. And that IT admin has permissions to connect to the server on the right, the target server, but it also manages different hosts, maybe supports the users, maybe installs softwares and things like that. Once he does that, he will usually leave behind his credentials in some way. It kind of depends on the operation system. There's a bunch of different techniques for us to do this as an attacker, but we can assume that once he logged onto that computer, he leaves some residue behind. It could be clear text password, it can be a hash of his password, or it can be session that we instill in some way. But once he does that, the attacker can actually connect to that host, gain control of those credentials, and then move forward to his target. So it looks something like this. Steal the credentials and get to the target. And you can probably already see some graph pattern being created here. So maybe now it's starting to look more familiar to what you're used to seeing in Neo4j. Now, the first people that took notice of this and really brought it to community, to the security community, as a company called SpectreOps with their open source tool called Bloodhound. Bloodhound really changed the game for attackers because they came and they wrote a tool to collect all this information from a Windows network and put it all on Neo4j and mapped out the graph that looks kind of similar to what we've seen before. So it would look something like this, and this should really look familiar to you folks out there. So let's say we have user Bob, which is a node. That user has a relationship or an edge of member of towards a group. That group is help desk. So user Bob is a member of the group help desk, meaning he has the same permission as that group. Now, assuming that group has admin permissions to a server called prod server 1, we can already say Bob has a path to prod server 1 because he is a member of that group, he has those permissions, and he can connect to the computer. Now, if we take that a step further, we say prod admin, the next node in line, has a session on that server, meaning we can steal those credentials. And also we can assume that that user has permissions to add itself to a group called domain admins. Now, domain admins in a Windows environment, that's the highest permissions you can have. That's kind of having the keys to the kingdom. So that's always a lucrative target for an attacker. So that's always something we look out for. So we have this graph here, and even though user Bob is not really directly related to domain admins, and in any you look up, it should have really simple permissions. You can see here that basically user Bob has the same permissions, effectively has the same permission as the domain admins, which is really dangerous. Now, in the cybersecurity, we have two opposing teams that we usually like to talk in colors. We have the red team and the blue team. Red team usually refers to the attackers, usually ethical hackers, people doing penetration testing and things like that, so simulating attacks. But for the sake of this environment, we can also include real-world attackers, either state-sponsored or organized crime or anything like that. And the blue team is the defenders. So we have the SOC, we have incident response, we have threat hunters, anything like that. Now, security has always kind of been unbalanced between these different forces. So the red team always had kind of the upper hand, and this happens because a lot of different reasons. But for the sake of this argument, I want to share something we call the red heaven and blue hell. And you'll see what I mean once I share a graph. So back to Bloodhound, and you can already recognize this as being Neo4j. As I said, you only need one valid path in order to be successful. So let's assume you're on that user on the left, and you know where you're starting, you know where you want to go. That's the domain admins group on the right. Again, the highest privileged group. And basically, you run the tool, you do a simple shortest path query from where you're starting to where you want to go. It takes a minute, and then you can see a really easy graph that tells you go from here to here, from here to here, and you get to a domain admin, you finish your project, job well done. But on the blue side, we have what we call blue hell, because we don't really know where the attacker will start. We don't know where they want to go. So we have a lot of different paths. It could be 10,000 paths, could be millions of paths in our network, and we don't really know where to start from. How do we even know what we need to fix if we don't know where we need to start and where we're trying to go? So in summary, what do defenders really need? So first thing is collection, just being able to collect all of the data that they need, easily, and be able to schedule it and everything like that. Analysis, meaning not everybody is a Neo4j expert. We want to really simplify it for folks that don't have the knowledge yet, or maybe are just starting to get into Neo4j and want to learn how to do the queries that they need, because coming from a classic SQL world, it might be kind of scary to get into it. So really want to give a lot of value out of the box. Customization is also a really big one. So Bloodhound, for example, deals mostly with permissions, so user permission, groups, things like that. But we want to take into consideration other things. So for example, network connectivity. Can host A in our path actually communicate with host B on the network side? If they can't really communicate, then that path is not really valid, because even though you are on host A and you have the right permissions, you won't be able to connect. Another thing is vulnerabilities. So if we have unpatched software that attackers can take control of, those are really big starting points for us to take into consideration. So really wanted to have the ability to add more information and more customization for everybody. And the last thing is the community side. Now, the red side has always been more open and willing to share. If you go on Twitter now, just look up a few different things. You'll find a lot of different, exploits being shared, a lot of different tools, open source, blogs, YouTube videos, whatever your heart desires. You can learn everything just by using Google. On the blue side, we have a tendency to keep things close to our chest. I think it might be because we're usually dealing more with enterprise that don't really want to share information about their network structure and things like that, or what they do to defend, because they don't want to give attackers that information. But we still want to take a step in the right direction. So when we started the project, the first thing we started with NeoDash. Now, if you don't know NeoDash, it's a really awesome open source project created by Niels de Jong from Neo4j. It's a dashboard, a visualization tool for Neo4j. It's a web application. You run it, and out of the box, you already get a visualization. You get a really cool Cypher query editor, the ability to share dashboards and things like that. So if you haven't checked that out before, you should really take a look at it. It's free, it's open source. You can do a lot of really cool things with it. And it really starts to help you taking that Neo4j, that graphical data, and presented it in ways that will be more useful maybe to people who are not used to working with graphs. So that when we saw that, we say, hey, that's really close to what we want to do. So we actually started by forking that project and created something we call BlueHound. So it's a fork of NeoDash, aimed to make the graph datasets more accessible for the blue team. But it has a bunch of other use cases, so it can be used basically for anyone, because it has a bunch of different changes that I'll go over from the classic NeoDash. Now, first thing is we compile it as a binary using a package called Electron. So now it's no longer a web app, or it is a web app behind the scene, but no longer need to run Node.js and a bunch of different things. You don't need to install anything. It's just portable, executable. You double click it and you get the interface. The only thing you need to install really is Neo4j other than that. Second thing is data collection automation. So we added, click of a button that lets you run all of your collection scripts, uploads it in Neo4j. You even have scheduling if you want to run it periodically, and you can add your own tools and collection if you want to. Increased coverage. So we added a bunch of different different scripts, which I mentioned earlier. One dealing with network connectivity, which now has in our graph. It says, can this host actually communicate with host B, or is the path only based on permission? And also parsing vulnerability reports in order to understand which hosts have critical issues that attackers could take control of. And we have a bunch of pre-built queries, again, in order to give a lot of value to somebody starting out with Neo4j, or even who doesn't even know what Neo4j is. You can open it, you can see all of the different things, and you can start getting into it, easily. So I'll quickly jump over to the interface just so I can show you some things, explain what it does and what it looks like. So this is the BlueHound interface. Again, as I said, basically a compiled binary. Here it's running on my Mac, but it's also available for Windows and Linux. So the first thing is we have to configure a few basic things. Domain controls, meaning what are the most critical servers. Domain controls are the servers that hold all of the, kind of like the heart of the soul of the Windows domain environment. So they have all of the password hashes of everybody. They have all of the configurations, everything like that. This is really the starting point, and this is really the goal for any attacker. The domain admin groups is the group that has the domain admin privileges. So as I mentioned earlier, the keys to the kingdom, that's always the biggest target. And crown jewels is a term we use to talk about additional servers that are really critical for us. So this could be HR servers holding HR information. This could be databases. It could be anything that we want to keep an eye out. So you can take a look here at the logical path, and this should already look familiar. So we have all of this path here. This is some queries that we predefined. So for example, we have path from vulnerable host. We have a short description here just to explain what it does. Let's just show it. So here, for example, using that information about unpatched issues or unpatched software, we can see that we have this host here. You can see that it has the is vulnerable true flag and CVEs. CVEs are a way for us to identify critical software issues that attackers use. And now, pretty simply, it's a shortest path query from each host that have critical issues on them, all the way to what we want to get. So with the domain admin groups, the domain controllers, a very simple path that gives us a lot of critical information. Now you might ask me, okay, well, this is nice, but why would I even have unpatched computers in my network? I mean, I'm supposed to patch everything all of the time, so I don't even need this path. I'll just patch everything and make sure I'm safe. That's nice and well, but in reality, in bigger companies, dealing with 10,000 hosts, 100,000 hosts, things tend to get a little more tricky, especially if you have critical servers that you can't restart for patches, or maybe you have a QA environment that you don't really care about and you don't bother to patch it ever, but there's some residue, there's some permission left over, or there's some path left over. So that's really the point, is that now we can start prioritizing what are issues we have to deal with. So today and not tomorrow, because these hosts are really critical for us to patch today and we can't wait for them until tomorrow. Or maybe there's a new vulnerability that came out today, and we're trying to gather all of our inventory, understand what do we need to patch and how to get started, and we can take us a week to get everything patched. So now we know these are the hosts that we have to patch today. We can't wait longer. And other hosts, yes, it's very important to patch them too, but we have a starting point. So that's the point of this query. We can also click here to see what the query looks like behind the scene. Again, it's pretty simple. So we have shortest path query from a computer, going through filter edges. I'll expand this in a second, to the group that we configured earlier, the domain admin groups, with the is vulnerable flag true. And this bit specifically deals with the network information because these paths don't take into consideration networking. So we just remove the network edges between them. And then we return it. So easy as that. Now, if I just mention the filtered edges, so we have this view over here when we can actually decide that we don't want to look at some edges. So again, I don't have to go and modify any of my queries, especially if I don't have, I don't have that skill set yet, or I don't want to go and deal with all the queries. You can just take them out here. This is useful because in some environments, they have some weird configuration or something like that, and then we can have a lot of paths with specific edges, and sometimes we just want to clear things up. So it's really easy just to filter it out. Yeah, and that's basically this query. So we have, again, a bunch of different things here running. I don't have time to go into all of the queries, but you can see, you can download the tool again for yourself and take a look at everything. We have network enabled path. Now, this is the same view as before, but taking into consideration the networking side of things. So you can see that all of the paths got really, all of the graphs got much lower because now we're looking at are these paths actually valid from a networking standpoint? And assuming we do have some firewalls or anything blocking networking and stopping, attackers from moving wherever they want, we should have a much, a lower view when we're looking at this path. So it'll be easier for us to, actually go and fix these issues when we know what are the issues that are actually possible for attacker to exploit. Moving on to the statistics tab, now we're getting into the realm of how do we share this information with other people? Not everybody talks in graphs. For me personally, I found that graphs are really useful when I want to really dig deep into things and find the issues and what are the clusters or what is the node that is giving me the most problem that I need to fix today. But when I want to share it with other teams or peers and have them actually fix those issues that I found, it's usually easier for them to get more classical views. So it could be charts, it could be tables, things like that. So for example, we have here the users with most paths to hosts. So we know what are the most critical users that we need to fix, for example. We also have these table views, or these all came out from NeoDash, but we did add the ability to export data to CSV, which is, again, very useful if you want to share that with other teams, if you're not doing all of the work by yourself and you want to, collaborate with other people. Next, taking even a higher view, we have the scores tab, which is kind of like a metric, showing us different things. It's really nice for management, or if we want to take, if we want to continue looking at our progress and see how we're doing. So we can see different percentages for example, what is the percent of hosts that we have in our network that have some critical vulnerability, or what is the percent of users with paths, and a bunch of different things here. This specific gauge chart was not a NeoDash, so it's something I added and then I committed back to the main project. So even if you don't want to run BlueHound, you can just download NeoDash and you'll have this there today. And this is some of our basic charts that we have here. So again, even if you've never used Neo4j and you don't know what it is, you can just download it and see some critical information and hopefully understand how to fix it. A few different changes from NeoDash that we have. So we have this query runner here. Now, NeoDash, whenever you open it, does all of the queries on the fly and gives you the information. Now, some of these queries do take a lot of time to process, and we don't want to, process it every time we open the tool. So we have this nice view that lets you see the queries themselves, and you can run each query by itself or do it in a parallel. Just click on the run all, and all of the data is being cached. So for example, when I close BlueHound and open it again, all of this data will still be cached on my host, and I don't have to run it again. Of course, I can always run it from here or from the query runner if I want to get the latest data, but I don't have to do it every time. I've already mentioned the filtered edges. We have the data import tools section. So this is where we actually run our collection tools. At the default, it's configured to run security tools, but again, you can of course add your own tools here. You just decide what kind of tool. If it's a binary, it's a Python script. You just point it to the tool path. You can give the arguments if you want to pass to it. And we even have this URL button. So if you've shared your dashboard with somebody else, you can just click on it, download the tool, save it locally, and have it being run from here. Again, you can run each tool by itself. You can run all of the tools together in parallel and serial, so pretty flexible. And even we added the scheduling, so you can decide if you want the collection to happen once a week, once a day, once a month, whatever it is. BlueHound will run behind the scenes, collect everything, put it into Neo4j, and basically, make everything easier for you. Next, we have the Save Dashboard. So this is something we got free out of the box with NeoDash, but we want to iterate because it's really powerful. Just the ability to save your dashboard. This doesn't save like your Neo4j database password or anything like that. Just the queries and all of the things that you set up. So it's a really nice way to share either for backup or share it with peers, or hopefully share it with community. So, in our case, the defensive security community can use this to share dashboards that we created, share queries that we created, and then we have one place, for all of the interesting queries that we created as a community. You can, of course, load it here and have everything, basically looking like this. So closing up, we have a bunch of links here. So first is, of course, for BlueHound. It's on our Git at GitHub at Zero Networks. We also have a bunch of other open source tools that might interest you if you're coming from the security community. We have some scripts to extend Bloodhound, and we have some other tools like the networking data and things like that. We have the blog post on our website that explain BlueHound in a little bit more detail if you want to also read about it and understand a few different use cases. Of course, I have to give a shout out to the Bloodhound because this is why we're even here. This was the start of everything. So get sure to check that out. And of course, NeoDash, which BlueHound is forked from. Again, BlueHound gives you a bunch of different things, but if you don't want any of that, you should still check out NeoDash because it's a really powerful, really easy way to create dashboards and visualize your data, even without trying to do it manually yourself. Thank you. So that's the summary. That's the end of my presentation. Again, you can find me at Dekel_Paz at Twitter. You could also reach out on LinkedIn or any social media.
Cool. Thank you very much, Dekel. Cool stuff. Very interesting. And yeah, cool presentation. Can I exactly, Andreas? Can I see the clapping emojis for Dekel, please? So virtual applause. We have a bit of time, so if you don't mind, Dekel, I can read a couple of questions that came in. So if you have a question for Dekel, now is your chance. We have 5 more minutes as part of this official session, and then we can, before we lead over to the final Q&A with Emil. So if you have a question for Dekel, please type it in the chat right now. First question comes from Stefano. About the is vulnerable flag. Is that automatically set, or is that a manual process? How does it work?
Sure. So I created a Python script that parses vulnerability scanners. So there are a bunch of different tools. Some of them commercial. So Qualys and Nessus are the big ones. But we also have a bunch of free ones like OpenVAS or Nmap. So basically, usually what will happen is you run those tools periodically in your network, and you get reports. And I just created a script that parses those reports and then automatically loads it into Neo4j. So you can either run it from BlueHound. Again, just check it out on our Git page if you just want that script by itself. And I guess you could probably do, a fully automatic solution where you connect to the API or things like that. But this was just a more POC. So if you already have those reports, it's a pretty automatic process to get that. If not, it's just a few clicks.
Okay, cool. Thank you for that. Let's get away. So one question here from Nadav. So is this like Bloodhound for enterprise? I guess you showed this a little bit. So can you maybe in a few words say what's the difference between BlueHound and Bloodhound?
Yeah, I think the question here refers to Bloodhound for enterprise. So the Bloodhound team actually created. I'm not sure if it's released yet or not, but they created a tool called Bloodhound for Enterprise. It's an enterprise version of Bloodhound. I haven't personally used it. I did, see their announcement, something like that. So I think their tool is more focused on just the running it automatically and giving you specifically the, the Bloodhound information in a more enterprise easy way. BlueHound, well, first of all, it's open source, so you can just get it. But we really want to create more of a context around it. So we don't want to deal just with user permission, because I think just one side of the story. We also have, again, the networking side of it, and we have the vulnerability side of it. So we're trying to create a larger story around that, and to really go and find the most critical issues, not only permission-based, but in general.
Okay. And then one more question from Stefano. How can because in the beginning you showed the red hell and the blue, the red heaven and the blue hell. So how can Bloodhound be used, or BlueHound how can it be used by attackers? I mean, how can they use it to graph the Active Directory's information before the target organization has been compromised? Or is it a tool useful? That's, I think, what you showed.
Yeah. So Bloodhound is used in attacks. The thing is that Bloodhound queries a lot of different things, but it does that with very minimal permissions. So you'd be surprised at the amount of information Windows hosts are happy to give you, even if you don't have high permissions. So that's what they use in order to build the graphs. So attackers do use it. They run just the collector side of it usually, get all of the data that they need, usually take it out to a server, some server outside of the organization, build the graph, see what, where they need to get to, and then just follow the graph. So it's used usually, again, in the middle stage of the attack, once we're already inside.
All right. Cool. And yeah, I think that gives us one time more for one more question from Michael. Did you add any drill down feature in the dashboard?
Not really sure what does Michael mean by drill down feature. We have, again, the bunch of different graphs that you can just investigate by yourself, go inside if you need to figure out why some issue is occurring. And we have the more tabular views or things like that to pinpoint, more specific host or computers that are related to a bunch of different paths, things like that. So nodes are probably really problematic. Usually that's a good starting point to understand what we need to fix, what's our priority. Then drilling down usually will be, if I understand the question, you have to start understanding why that host or why that user has that permission, or why that computer, has that session. Usually the answer will be that there's no really good reason. It just happened because some, historic events or things like that. But it could depend, it's different between enterprise and enterprise.
Yeah. Okay, cool. Thank you very much, Dekel. That brings us around to the end of your session. So again, thank you for presenting. Thank you for the demo and for answering a couple of the questions. I hope to see you soon at another event or somewhere else. Thank you, Dekel.
Thank you. Thank you for having me.